Hello everyone, my name is Welly from Education Delivery Team Palo Alto Networks. Today I'm going to show you the Large Scale VPN, aka LSVPN configuration tutorial in Palo Alto Networks firewall. This will be our topology that we will use on this LSVPN tutorial demo video. We have one global protect portal, three global protect gateways for IPsec VPN tunnel point to multi-point terminations to satellite firewalls. The interface Ethernet E1/6 is representing the external public-facing interfaces, so all the initial communications will start from there. Once the LSVPN successfully implemented, all the satellite offices will have the reachability to the subnet protected behind the gateway firewalls, and also getting the internet connectivity via the IPsec VPN tunnel. Now let's take a look for a while the configuration tasks that we will do on these demo presentations. And you can always referring back to this checklist again later on. At first, we will start with the preparations for SSL certificate on all LSVPN components since the firewall will need this certificate on authentication stage. And then, we are moving forward to configure the Global Protect Gateway components, the portal, and the satellite firewalls. So, let's start with the SSL certificate preparations phase. At the moment, we are in the portal firewall. For the client certificate validations, we can use either OCSP or CRL method. In this tutorial, I'm going to use portal as the OCSP responder. The next important step in your certificate preparations, we need to have the CA certificate. Deployment options, you can choose to get public commercial CA, internal CA, or the self-signed CA by the firewall itself. This CA cert need to be accessed and available on all the LSVPN firewall components. For this tutorial, we will generate self-signed CA certificate in the portal firewall. After the generation successful, click the cert and making sure that it is selected as the trusted root CA. Now, we have the CA cert ready. We will then generate the portal certificate. We use the portal FQDN address, and the signer will be the CA cert that we have created earlier. We'll attach the OCSP responder on every server certificate generation process. Since now we have the portal certificate ready, we can configure TLS profile for the portal firewall using its portal certificate. This profile will be used when initial authentications coming from the satellite firewall. We come back to the certificate settings since we also need to generate a server certificates for the gateway firewalls, gateway 1, 2, and 3. We show you here only how to generate the gateway 1 server certificate. The rest of the gateway will be done on the background using the same step. What happens next is we need to export the CA cert and the gateway cert out from the portal. The recommendations is to export CA certificate in the PEM format so that we don't expose any private keys. And for the gateway certificate, we will export it in the PKCS format with the password for encrypting the private keys. Now I will hover my mouse to the gateway firewall and we want to import two certificates here. The first certificate that we want to import is the CA cert. So we give a name and browse the cert locations. Once the import is successful, we mark it as the trusted root CA certificate. The second certificate that we want to import is the gateway server certificate. So we give a name, browse the locations, change the file format to the PKCS, and put the same password as what we exported earlier. Same like portal firewall, we also need to have TLS profile in the gateway. This will be used on SSL negotiations between the gateway and the satellite firewall. In addition to that, the certificate profile need to be configured so that the gateway can validate the certificate that is sent by the satellite firewall. We will add the CA cert here and put the portal address locations in the OCSP URL settings. Check the OCSP and set the block conditions if the certificate validation is having a problem. Lastly, we're going to move to the edge of the satellite and import the CS certificate to the firewall. Browse the locations, upload the cert, and mark it as the trusted root CA. We don't have to manually create the satellite certificate because during the initial communications, the satellites will submit the CSR to the portal and the satellite certificate will be pushed by the portal and installed by the satellite during the registration phase. We still need to have the certificate profile to perform mutual authentications between satellite and the gateway firewall. So again, we use the OCSP and put the same condition settings. So that's all. The certificate preparation phase is done and we need to repeat the same steps to the rest of the gateway and the satellite participants in the LSVPN. After we complete the SSL certificate preparation phase, we're going to move to the gateway firewall again to complete the LSVPN configurations. Looking at the network interfaces here, we have E1/1, this is our internet connections, E1/2, the intranet private network protected behind the gateway, and E1/6, the public external interface to communicate to the other's LSVPN firewall. E1/6 will have the OCSP enabled on its management profile to get the certificate validation from the portal. What we need to do here is to create a tunnel interface, give the tunnel ID .100 in this example, assign the feature router and the security zones. Please bear in mind that we need to also configure the security and NAT policy accordingly based on your traffic requirement. We configure the IP addresses 10.100.100.101/24, and this gateway tunnel IP will be the next hop on the routing table from your satellite firewall. Okay, the interfaces requirement is ready. Now we will start the general global protect gateway configurations by giving the name and use E1/6 for the initial LSVPN communications. In the authentication settings, we put gateway TLS profile for the server authentications and the certificate profile for the client authentications. Move to the satellite settings. We tick the tunnel configurations and choose the tunnel interfaces .100. The 2 hours is the timers how often the satellite will check the portal for the configurations updates. We will enable the tunnel monitoring on this tutorial and we will test it on the failover scenario. If we leave the empty value on here, it means the satellite firewall will monitor the IP in the gateway tunnel interface to verify the up-down status. On your monitor profile, we must use the failover mode. Down at the bottom, you can modify the crypto proposal settings here if you don't want to use the default crypto profile for your IPsec tunnel. Shift to the network tab. For this tutorial, we just put the public DNS IP. And then for IP pool settings, this is the range of IP addresses that will be assigned dynamically to the satellite tunnel interface. The access route will determine what prefixes to be injected to the satellite firewall routing table. Gateway 1 in this tutorial will advertise the specific intranet subnet 11.11.11.0/24 and also the default route to the satellite. The purpose by doing this is the satellite will understand that subnet 11 is only exists behind the gateway 1 and the route will be taking the direct path. In the route filtering tab, we can make the gateway firewall to accept the specific prefixes published by the satellite so that the gateway will have the knowledge for routing back the packet to the satellite. And it's done. The LSVPN configuration in the gateway, we hit the commit. Now we hover back to our portal device. As we can see, the E1/6 interface has been pre-configured. We go for Global Protect Portal Configurations by give a name and choose the E1/6 for the Layer 3 interface to communicate to the other LSVPN firewall. Under Authentications, we put the TLS profile for the server authentications, and we are going to use Radius as an authentication fallback mechanism. Down to the satellite settings, we choose the CA certificate for the trusted root and the signer of the satellite firewall certificate. The satellite certificate lifetime will be expired in 7 days, and the renewal from the portal will be happening every 3 days. Remember, we're going to use OCSP for the certificate validations. Next, we add the satellite config. We can manually import the serial number of our satellite device. If the satellite serial number is not exist during the registration phase, the portal will fall back using the client Redis authentications. In this tutorial, we will register satellite 2 serial number, so later on, we don't have to manually enter the credentials. And for satellite 1, since the serial number is not available on the portal yet, we expect the administrator to key in the Redis credential on the registration phase. Lastly, we're going to put all the lists of the gateway addresses, gateway 1, 2, and 3. We can use FQDN or IP address of the gateway, and the routing priority will determine the metric value on the satellite firewall routing table. The metric calculation formula will be times 10 of the gateway routing priority. So, in this tutorial, satellite firewall will have metric 10 from gateway 1, 20 from gateway 2, and 30 from the gateway 3. After this, we commit the portal and move to the last component of our LSVPN, which is the satellite firewall. In the satellite is pretty straightforward. Again, we need to prepare the layer 3 interface, and we have already pre-configured the E1/6 interface. We will then need to add the tunnel interface, giving the tunnel ID, assign the virtual router, and the security zones. Since we are using a static root on this tutorial, IP address is not mandatory, and it will be dynamically assigned by the gateway from its IP pool. Then we add the IPsec tunnel, give a name, and choose the tunnel interface that we created earlier. And the type of the IPsec tunnel will be the global product satellite. Key in the FQDN of the portal address and select E1/6 for the satellite initial communications to the portal and the gateway firewall. Under Advanced tab, we can configure the satellite to publish the connected and static route to the gateway firewall. This information will be required if there is no address translation from the satellite firewall. Thus, the gateway firewall needs to know how to route the packet back to the satellite. And that's it. We commit the satellite and we are ready for the LSVPN verification. Now let's see the status of the IPsec tunnel on satellite 1. After the commit, it's still showing down. This is because earlier we don't register the satellite 1 serial number, so the portal will reply with the HTTP 401 authentication error and fall back to challenge using the Radius method. We have to manually enter the Radius credentials, and the connections will be reinitialized to the portal. While we are waiting them to reconnect, let's have a quick look on satellite 2 firewall and see the IPsec status there. We can see there is no authentication error happening here since the portal already have the satellite 2 information serial number, and then it will generate the certificate to the satellite directly. Once the authentication is successful, the satellite will receive the list of gateway and start to build and establish the tunnel. In tunnel details, we can verify the tunnel gateway IP, the dynamic IP tunnel assignment, and the injection route from the gateway. In the satellite routing table, we can see default routes are being injected from 3 gateways. However, since gateway 1 has the lowest metric, 10 in this example, it will be selected as the active route. So when the satellite wants to go to the internet, it will prefer gateway 1 as the next hop. For the specific intranet prefixes, all the gateway will be the active routes since all of them are publishing a different subnets. Means the satellite will take the specific path to the gateway respectively. Now let's come back again to satellite 1 and see after the authentication fallback successful, the tunnel will show up and the rest of the output informations will be the same in comparison to the satellite 2 firewall. Next, let's see the gateway and click the satellite info. We can verify how many satellites are connected. Currently, we have 2 satellites active, satellite 1 and satellite 2. And we can see each satellite IP informations, their tunnel, their public layer 3 interface, and also the accepted prefixes that is published from the respective satellite firewall. In the portal device, we can check the satellite device informations such as the hostname, serial numbers of the satellites that successfully registered. We can get the informations when is the last time the satellites connect to the portal and the certificate status of the satellite with their expiration date. The last thing that we want to do is to test the tunnel monitoring features. In satellite firewall, now we can see the green light indication showing all tunnels monitoring are up. Next, we go to the PC behind satellite 1 firewall and we are going to verify the route path taken from the satellite 1 office by doing the trace route. The traffic that going to subnet 11 behind gateway 1 is going direct to tunnel 101. The traffic going to the subnet 22 behind the gateway 2 is taking a path direct to tunnel 102. For the internet traffic to the public 8888, the traffic taken is via gateway 1 tunnel. Now, we ping continuously to 8888, which is the internet, and we want to test the failover scenario by bringing down the gateway 1 connections. To simulate the failure conditions, we will choose the E1/6 here and change the interface state to down. We will then commit the gateway and see if the failover works on the satellite office. Once the primary path to the internet via gateway 1 tunnel is having the reachability problem, we will see the ping drop to the internet because at the moment, the monitor profile is still trying to test the gateway 1 tunnel connections. After a while, the internet connections is restored, and when we do the trace again, the traffic is taking a different path and shifted to the gateway 2 tunnel. We can verify the tunnel monitoring is down to gateway 1, and the routing table in the satellite will have the active default route is now going via the tunnel gateway 2. That's all for the LSVPN demo, and thank you for watching.